Hello everyone and welcome to the lecture on AWS CloudHSM, and HSM stands for Hardware Security Module. So what this lecture will contain all these topics. What is AWS CloudHSM, AWS CloudHSM benefits, AWS CloudHSM use cases, how AWS CloudHSM works, AWS CloudHSM clusters, HSM users in CloudHSM, HSM keys, key usage and management principles of CloudHSM, and backups. So what is AWS CloudHSM? AWS CloudHSM provides dedicated hardware security module HSM instances within the AWS cloud, offering an additional layer of security for sensitive data and cryptographic keys. The service helps organizations meet various compliance requirements for data security, such as corporate policies, contractual obligations, and regulatory mandates. While AWS and AWS Marketplace partners offers a range of data protection solutions, CloudHSM complements these by providing additional protection for applications and data subject to stringent key management requirements. With AWS CloudHSM, users can securely generate, store, and manage cryptographic keys used for data encryption, ensuring that the keys are protected within HSMs. The HSMs used in AWS CloudHSMs are designed and validated to meet rigorous government standards for secure key management, providing a high level of assurance. CloudHSM ensures that the cryptographic keys are accessible only by the user, maintaining strict control over key usage, key access, and key usage. So AWS CloudHSM benefits. So AWS CloudHSM uses general purpose HSMs that are standards compliant, single tenant, and FIPS 140-2 level 3 validated. They provide more flexibility when compared to the fully managed AWS services that have predetermined algorithms and key lengths for your applications. Because your data plane is end-to-end encrypted and not visible to AWS, you control your own user management outside of IAM roles and IAM user management. And the trade-off for this control is that you have more responsibility than if you used a managed AWS service. 3. AWS CloudHSM gives you full control of the algorithms and keys you use. You can generate, store, import, export, manage, and use cryptographic keys, including session keys, token keys, symmetric keys, and asymmetric key pairs. Additionally, AWS CloudHSM SDKs give you full control over application development, application language, threading, and where your application physically exists. Next generation CNG, cryptographic next generation, or key storage providers, KSP, can migrate to AWS CloudHSM with fewer changes to their application. So just one point to bring in, AWS KMS is key management service, but the hardware or the infrastructure is not in your control. So if you want more stricter control or regulatory requirements, then you go for CloudHSM, where even the hardware, even though it's in the cloud, will be under your ownership and you will be responsible for all the key management. So some AWS CloudHSM use cases. So businesses that need to align with enterprise security standards can use CloudHSM to manage private keys that protect highly confidential data. The HSMs provided by CloudHSM are FIPS 142 level 3 certified and comply with PCI DSS. Additionally, AWS CloudHSM is PCI PIN compliant and PCI 3DS compliant. So these are some standards. Use AWS CloudHSM to manage private keys that protect highly confidential data, encryption in transit, and encryption at rest. Additionally, AWS CloudHSM offers standards compliant integration with multiple cryptographic SDKs. In cryptography, use a private key to sign a document allows recipients to use a public key to verify that you and not someone else actually sent the data. Use AWS CloudHSM to create asymmetric public and private key pairs that are specifically designed for this purpose. In cryptography, cipher message authentication codes, CMACs, and hash-based message authentication codes, HMACs, are used to authenticate and ensure the integrity of messages sent over unsafe networks. With AWS CloudHSM, you can securely create and manage symmetric keys that support HMAX and CMAX. Customers can combine AWS CloudHSM and AWS KMS to store key material in a single tenant environment that is FIPS 140-2 level 3 certified, while also getting the key management, scaling and cloud integration benefits of AWS KMS. To securely send data over the internet, web servers use public private key pairs and SSL TLS public key certificates to establish HTTPS session. This process involves a lot of computation for web servers, but you can reduce computational burden while providing extra security by offloading some of this to your AWS CloudHSM cluster. Transparent data encryption (TDE) is used to encrypt database files. Using TDE, database software encrypts data before storing it on disk. You can achieve greater security by storing the TDE master encryption keys in HSM in your CloudHSM. A certificate authority (CA) is a trusted entity that issues digital certificates that bind the public key to an identity, a person or an organization. To operate a certificate authority, you must maintain trust by protecting the private key that signs certificates issued by your certificate authorities. You can store such private keys in your AWS CloudHSM cluster, then use your HSMs to perform cryptographic signing operations. Generating random numbers. So you can generate random numbers to create encryption keys is core to online security. And AWS CloudHSM can be used to securely generate random numbers in HSMs you control and are only visible to you. So how AWS CloudHSM works? AWS CloudHSM operates in your Amazon Virtual Private Cloud VPC. So before you can use AWS CloudHSM, you must create a cluster, add HSMs to it, and then create users and keys, and then use client SDKs to integrate your HSMs with your applications. And once this is done, you will use your client SDK. You use client SDK logs, AWS CloudTrail, audit logs, and Amazon CloudWatch to monitor AWS CloudHSM. So it's something about some information about AWS CloudHSM clusters. CloudHSM simplifies the process of creating synchronized, redundant and highly available clusters of hardware security modules, which can be challenging to set up individually. When an operation is performed on one HSM in a cluster, AWS CloudHSM automatically updates the other HSMs, ensuring they remain in sync. So there are 6 per AWS per region. HSMs can be created and distribute them across multiple availability zones to meet high availability, durability and scalability requirements. So default is 6 per account per region, but you can spread it across multiple AZ zone. So adding more HSMs to a cluster can improve overall performance, allowing users to handle increased workloads efficiently. And by spreading HSM clusters across multiple availability zones, users can achieve greater redundancy and high availability for their sensitive cryptographic operations. So just want to correct myself. So you can have in a cluster up to 28 HSM. So default will be 6. Default limit is 6, but you can go up to 28, and these 28 you can spread across multiple availability zones. So I have placed one HSM in one AZ, 2, 3, and let's say you have 3. Most of the region have 3 at least AZ, right? So if you have maximum count of 28, so you can place them in all 3. So you can have 9, 9, 9, and one can have 10. So this is the maximum. But some regions have 6 also availability zones, so you can spread across. So 28 divided by 6, you can spread it across and round to some number. So you can have that kind of configuration also possible. So in case of let's say 6, you can place around let's say 5, 5, 5 in each availability zone, and some of them you can put 4. So that's how you spread it across. But the default will be 6 per account per region. So that is the default limit. So talking about HSM users in Cloud HSM, unlike most AWS services and resources, you do not use AWS Identity and Access Management (IAM) users or IAM policies to access resources within your Cloud HSM clusters. Instead of using IAM users, you use HSM users directly on the hardware security modules in your AWS Cloud HSM cluster. IAM users who have the correct credentials can create HSMs by interacting with resources through AWS API. So basically we are using IAM APIs to manage the Cloud HSM, but the users of Cloud HSM will be its own users. So Cloud HSM will have, you have to create users directly in Cloud HSM cluster. They are not part of IAM, but IAM users will manage the overall product. Like they are the administrator who just manage the service, but inside this box everything is belonging to Cloud HSM cluster. It has its own users, it has its own keys and policies. Since end-to-end encryption is not visible to AWS, you must use HSM user credentials to authenticate operations on the HSM. The HSM authenticates each HSM user by means of credentials that you defined and manage, and this authentication takes place directly on the HSM. Each HSM user has a type that determines which operations that user can perform on the HSM, and you define HSM user credentials using the AWS Cloud HSM command line interface CLI. So there's Cloud HSM CLI also. So user type, you can just think of some kind of a role. So based on that user type, they can perform different set of operations. Okay, next something about HSM keys. AWS Cloud HSM allows you to securely generate, store and manage your encryption keys in a single tenant HSMs that are in your AWS Cloud HSM cluster. And keys can be symmetric or asymmetric, can be session keys, which are ephemeral keys for a single session. They can be token keys, which are persistent keys for long-term use. Keys can be exported from and imported into Cloud HSM. And keys can also be used to complete common cryptographic tasks and functions. So you can perform cryptographic data signing and signature verification with both symmetric and asymmetric encryption algorithms. You can work with hash functions to compute message digest and hash-based message authentication codes, HMACs. You can wrap and protect other keys, and you can access cryptographically secure random data. So next is key usage and management principles. So many key types. So AWS Cloud HSM offers foundational principles for key usage and management. So let's see what are those. So there are many key types and algorithms to choose from, and to allow Cloud HSM allow you to customize your own solutions. AWS Cloud HSM provides many key types and algorithms to choose from. Algorithms support a range of key sizes, so it can be like you would have seen like 1024, 2048, 4096 kind of different key sizes. So it supports a variety of key sizes. And some of the algorithms that it supports is PKCS number 11 library, OpenSSL dynamic engine, JCE provider, cryptographic API, so next generation CNG, and key storage provider KSP for Microsoft Windows. So these are some of the algorithms that it supports. Key management. AWS Cloud HSM keys are managed through SDKs and command line tools. In Cloud HSM, you can use one of the following to manage keys on the HSMs in your cluster. So again, this is similar like PKCS 11 library, JCE provider, CNG and KSP providers, and Cloud HSM CLI. To use this to manage the keys for other keys basically. And before you can manage keys, you must log in to the HSM with the username and password of a crypto user. It's called a crypto user CU. Only a crypto user can create a key. The crypto user who creates a key, the crypto user who creates a key owns and manages that key. So the creator is the owner plus manager of that key. Key ownership. So in Cloud HSM, the crypto user who creates the key owns it. So I already talked about the owner can use the key share and key unshare commands to share and unshare the key with other crypto users. So in Cloud HSM, they are called as crypto users. And access and usage can be controlled with attribute-based encryption. Cloud HSM allows you to use attribute-based encryption, which is a form of encryption that lets you use key attributes to control who can decrypt data based on policies. So something about backups. AWS Cloud HSM makes periodic backups of the users, keys and policies in the cluster. Backups are secure, durable and updated on a predictable schedule. And the following diagram shows the relationship of your backups to the cluster. So when AWS Cloud HSM makes a backup from the HSM encrypts all of its data before sending it to AWS Cloud HSM. The data never leaves the HSM in a plain text format. Additionally, backups cannot be decrypted by AWS because AWS does not have access to key used to decrypt the backups. AWS Cloud HSM stores backups in a service-controlled Amazon Simple Storage Amazon S3 bucket in the same region as your cluster, and backups have a 99.79 durability, the same as any object stored in this Amazon S3. So this is standard durability. So basically this is a service controlled account in the same region. So it will just create a bucket for this specific purpose, but it will be a service controlled AWS account where it will be safely securing the backups, and this cannot be decrypted by AWS. And that's all. Thanks for watching.